Hello guys, welcome to my channel Valtech. Okay, so we are still on network address translation and this is the third video in the series. So today we are going to be talking about port address translation, which is also a type of NAT. Okay, so in our previous video we discussed dynamic NAT, in which we dynamically mapped private IP addresses to public IP addresses, okay, in order to allow internal network to communicate with devices over the internet. Okay, so today we are going to be talking about PAT, which is port address translation. It works a bit different with respect to dynamic, in a sense that you notice that in the last two videos regarding that, we were basically mapping individual public IPs to specific global addresses or global IP addresses or public IP addresses. Okay, this time round what we are going to be doing is all devices within our internal network are all going to be sharing a single global IP address or a single public IP. This is the way NAT is actually implemented in the real world. This is what you most often be configuring as a network engineer most often. So let's get right into it. So what it means is that in this network we have just a single network. Okay, that is 10.1.1.0 with two devices in the network. We have 10.1.1 and PC2, which has 10.1.1.2. So now, instead of individually mapping these addresses, this private IPs to some specific IP addresses, public IP addresses or global IPs, whether dynamically or statically, this time around these two IPs are going to share a single IP address, okay, which would then allow for communication over the internet. So we are going to be using, so most often in the role what we do is that we map our internal network IPs to our internet facing interface on our gateway router or our gateway, which is this. As you can see, 8.1.1 is our internet facing interface. So all these devices on internal network are going to be translated to this single IP here in order to allow communication over devices on the outside network. So that's what we are going to be doing. All right, so let's get on with it. So as you well know, from now we need to specify our inside and outside network. Okay, so interface F0/0, so IP NAT inside. Okay, then interface F2/0 is going to be our outside interface, right? So now we need to create a pool for our internal network. Okay, you could also statically just pick one and maybe assign it to this specific interface. That's one way to do it. But we are assuming that we have so many computers or end devices within this network, so we will create a pool for our 10.1.1.0 network. So IP access list standard 1. Okay, so permit 10.1.1.0 0.0.255. Okay, we are good to go. We've created our pool here. Right, so the next thing for us to do is to then configure NAT. So IP NAT inside as usual with our source. Want to translate the source. So right, so since we created a list for our devices which is in our local network or local segment, we are going to specify the pool of addresses we created, which is access list 1. Okay, so now this time round we are not going to be using dynamic, which is the pool. No, we want to map it to a single IP. So all these IP addresses in the pool we created are going to map to this single IP, which is on our internet facing interface. Okay, so that means we need to select this one, interface. Then we need to specify the interface, right? So the interface is fast Ethernet. Fast Ethernet 2/0. Okay, then we need to use this command, overload. So this command is what actually makes sure that all these IP addresses will be able to be mapped to this 8.1.1.1. okay, so as it says, overload and address translation. So we use this command, overload. So this overload is what helps to configure NAT port address translation. So we are done. So now before we test this, I just want to make something clear here. So the reason why we call this configuration port address translation is that I'm pretty sure you are asking that, okay, so since these two devices are being mapped 8.1.1, how does the outside network or the network differentiate between traffic sent to either of these devices? That is where port comes in, port numbers comes in. Okay, so when these devices communicate on the internet, the router here automatically assigns an ephemeral port number, which is kind of like a random port number, to their IP addresses mapped directly to this. Okay, so when there's a response, okay, or a reply from a device over the internet, based on the port number, the destination port number, the router here will be able to differentiate that, yeah, it is going to either PC1 or PC2. Let's test it out. Let's demonstrate so you guys see it clearly. So from PC1, I'm going to ping PC here, which is on the internet. Okay, so 8.1.1.2. okay, our pings are working perfectly. So now let's see what's happening. So do show IP NAT translations. So notice something here. When our network, our inside PC here 10.1.1 was trying to communicate with this device over the internet, it used from its inside local IP 10.1.1, it was assigned this port number 16883. okay, so now when it was mapped to our interface IP here, which is 8.1.1, you realize that it still maintained that port number, because that is what differentiated it from the traffic coming from. That's what uniquely identifies it from other devices. Yeah, so on the return traffic, as you can see on the return traffic here, it will use the PC. The PC also use the device from the internet has its own port number assigned, which, where is it? That's 8.1.1.2 here. As you can see, also generated its own ephemeral port number and then sent it to 10.1.1 using this particular port number. So it's basically the port numbers which the router here used to differentiate traffic to either of these devices. Even though they are sharing the same IP addresses, the port numbers differentiate them. So where's PC2? Let's ping as well. PC2, ping the device on the internet. Okay, PC2 is unable to ping. Oh, okay. Let's see. Let's troubleshoot. Let's do a little bit of troubleshooting here. Okay, so PC2 is assigned this IP, which I think I forgot to change it. So let's make the changes. 10.1.1.2/24 with a gateway IP of 10.1.1.254. okay. Okay, I think we are good to go now. So now let's ping. All right, pings are working perfectly now. Okay, so router 2, let's see what happens. Right, so as you can see, router 2 PC2, which has an IP address of 10.1.1.2 here, generated a port number of 50419 for the traffic which was sent to what, to 8.1.1.2. so the return on the return traffic, 8.1.1.2 also generated its own ephemeral port number in order to uniquely communicate with what, with 10.1.1.2, because it is always going to be translated to 8.1.1 for this interface. So basically what you guys need to understand is that all devices in our internal network here is mapped to a single IP. Okay, and that IP is always or is often the IP, our internet facing interface. Okay, so now the way for the router here to differentiate traffic going to either devices, any device within our internal network, it uses the port numbers. Okay, the port numbers generated by these devices when traffic is going to or fro. So when there's a traffic coming directly for PC1 based on the port number generated for that communication here, that traffic will go to PC1 and not PC2. The same process too goes for PC2 as well. Yeah, so I believe that will be all for now. So I'll be making another video. Okay, I'll be making another video, and that one is going to detail how you apply network address translation to servers that you want people over the internet or device over the internet to access. Okay, there's actually a more efficient way of configuring that, so stay tuned for that video as well. So guys, if you like the video, just hit the like button and also subscribe if you haven't yet done that. You are free to leave comments and also suggestions, and I'll attend to it. So thank you very much.